Hey everyone, today we're going to take a look at different types of forces, which is going to be a follow-up to my introduction to forces and dynamics. So the first thing when talking about different types of forces is to look at the two different kind of sets of forces. And we call these everyday forces and fundamental forces of nature. And fundamental forces of nature are all sorts of different things which have to deal with how molecules and atoms move and how we do energy and electromagnetics, and none of it is relevant for this unit. We're just going to focus on everyday forces. Now, out of these everyday forces, there are 6 of them, and we're going to go through them each, but it's important to understand that 5 of these forces are what are called contact forces, and contact forces mean that they only happen when things are actually physically touching in the world. There is one of these 6 forces which is a non-contact force, and that is the force of gravity, which is obviously does not have to be touching an object to work. Gravity happens all the time, regardless of where an object is on the planet. So remember, 5 contact forces, 1 non-contact force, and we're going to go through all of them right here. So I'm going to just start by listing them all off, and then I'll go in depth with each specific one. So the forces that we are going to deal with are Fg, which is the force of gravity, gravitational force. We have Fn, which are normal forces. We have Fa, which are active forces. We have Ft, which are tension forces. We have Fk, which are kinetic friction forces. And then finally we have Fs, which are static friction forces. So these are the forces we're going to deal with. These last two are pretty related because they're both friction forces, and all the ones except for gravity are contact forces. So I'm going to now go and kind of talk about each one specifically so that we're clear on how they work. Okay, so the first force we're going to look at is gravity. Now, gravitational force is probably the easiest one to understand because we're all familiar with it on a daily basis. It's the force that means if I have an object and I drop that object toward the ground, that it will fall toward the ground. It will not fly up into space. It's the force that's keeping you from going into the solar system, and it's keeping you on the planet. From the perspective of physics, we almost always consider that gravity is downward. So if you have an object here, gravity is downward. In almost every case, it's very unusual to have anything different. So you can pretty much always assume that gravity is straight down in every diagram you will draw. And we're going to get into these types of diagrams, which are free body diagrams, in a separate video. So that is the force of gravity, and it's pretty straightforward. It's just the force that makes things fall downward. Next up is the Fn, or normal forces. And normal forces are interesting, but they're not very complicated. But they're kind of counterintuitive to understand. So a normal force is the force that keeps things from falling through other things. So it only applies when you have two things which are directly in contact, and then it will keep them from falling through. For example, we remember that a force is just something that gives an object an acceleration or changes its velocity. So the force of gravity is changing my velocity, or giving me an acceleration that is pushing me downward toward the center of the Earth. And that's what's keeping me from floating away into space. But why, for instance, am I not just going through the ground into the center of the Earth? Well, that's because the force of gravity is being counteracted by a normal force of the ground, which is preventing my feet from going through the ground. And that's what normal forces are. Normal forces are always perpendicular to a surface. That means if you have a surface here, the normal force is facing away from it and at a right angle. and this is the normal force. Normal forces happen anytime you have two objects or an object and a surface that interact, and they're everywhere, and they're very important for counteracting the forces of gravity so that we stay on the planet and don't go through the planet. Next up are active forces. These are forces that result when an object makes contact, but it actually does something to it. It pushes it or it pulls it. So active forces are the forces that have action. If I push something or I pull on something, that is an active force. Usually, but not always, we're talking about active forces in context with humans who are doing things. But active forces, remember, are kind of the stereotypical force. They're forces which are pushes or pulls. Unlike gravity and normal forces, which have specific directions that they always are, active forces can be in literally any direction depending on where that push or pull is coming. Next up, we have tension forces. Tension forces are kind of an interesting force. They are forces of pulling from a rope or a string or other thing which has some sort of tension. For example, in a game of tug of war, you have that tension pulling on the string. Now, tension forces always go toward the string. You might have seen a diagram similar to this, and you'll note that the tension force is always going toward the center of the string. So it's going this way because it's pulling that object toward that rope or string. And these are tension forces. We'll learn more about these in a later video, more detail, but for now, that's really all you need to know about them. Finally, we have the two friction forces. Now, friction is just when you have two objects which are sliding one on another. Friction tends to oppose that sliding. It doesn't want it to happen. Friction is the force that makes, for example, it hard to push an object like a box across the floor. There is friction from that floor and from the box, which is making that motion difficult. Now, there are two types of friction, kinetic and static, basically moving and not moving. Kinetic friction is an object which is moving is being opposed and slowed down by the floor or some other object, whereas static friction is actually you are trying to move an object and it is not moving because of that friction. So a typical example would be, let's say you're moving a box, let's say you're changing houses, you're moving this heavy box. Initially, you need to push the box enough that it'll start moving across the floor. So here's the box, here's the floor. You need to push on it. That's exerting an active force. Remember, we dealt with active forces on the box. But there's friction here, which is going the opposite direction. And it's going the opposite direction because it's opposing you from moving it. And this is a static friction force because you have not started moving the box and it's preventing you from doing so. But once you've started moving the box and the box is moving, now you're in a path of movement. That active force is continuing, but you now are dealing with a different friction force. This is a kinetic friction force because this is kinetic motion. The box is moving. And that's the difference between the kinetic and the static friction forces. So that's essentially all there is here. There are these 6 types of forces which we are going to be dealing with in the unit. In the next video, we're going to look at drawing free body diagrams, which are similar to the diagrams I've been drawing here, which are going to help you take systems, that is like essentially pictures of motion, and convert them into a form where you can then analyze them and answer questions about their forces. But for now, that's all we're going to be doing, and thanks for watching.